So if you ever took Calculus 2 and learned integration by parts, by memorizing that little table that they give you, what you're doing is actually this. So you don't have to just memorize the table and the formula. So if you get a function, I don't know, something like that, and this is your function f, well, if you turned it this way and integrated this here, you could just call this function g, like if you integrated down this axis instead of integrated over this axis. So if you made, see how that's a function, and that's a function, you just make a box. The area of that box is just fg, and it's going to be equal to the integral of f dg, which is that, and the integral of g df. So you have fg, the total area of the box, is equal to integral f dg plus the integral of g df. And if you replace this with the variables that are normally used and subtract this term, you get, well, I'll just subtract the term first. Fg minus integral g df is equal to integral f dg. And if I replace these variables with the ones that are normally used, you get uv minus integral v du is equal to integral u dv. And that's integration by parts. And what you're doing, this is a technique to solve an integral for a function that's complicated. So what this is essentially saying is, if you don't know this area here and it's too complicated to just integrate with one integral, what you can do is you can make a box which creates another function that you're integrating down this axis. Well, you're really integrating up that axis, but that total area is equal to the sum of both of those integrals. And then they just arrange it funny, when they teach it to you. But that's really what you're doing, is you're just integrating a little bit extra on top of that function to make it a whole area, and then subtracting out the integral you don't want.